Good evening to you. So I am Shovik, a PMRF research scholar at IIT Bombay. I hope you can hear me. So we will be discussing assignment 4 today of the previous run of the course Power System Analysis. I'll be sharing my screen. So just a minute. Yeah, okay, Lakshman. Yeah, you can speak, Lakshman. Hello.
Hello, am I audible?
Yeah, yeah.
Okay. I just wanted to ask one thing before the start of session. I have
Yeah.
just sent an email to the NOC120. Okay,
Okay.
like for requesting for allowing the calculators in the exam halls, because I have just gone through the exam rules. There, it was mentioned that they are allowed to use the calculator that is available on the screen. But for this paper, I guess this is not going to work out. We
See, first of all, I am not permitted to answer any of that because I am not looking into that. So, since you have mailed NPTEL team, so they will be replying back to you. But as far as I know, calculators are mostly not allowed. So you have to use the on-screen calculator.
Yes, that is what I am just going to complete the part. So when I inquired the NPTEL services, they told that to inquire or to ask it in the discussion forum itself, to discuss about it in the raise it in the forum. That is what they have told. I got
Okay,
reply mail
so
from them.
then see the course instructor along with the course TA. I mean, I am an external TA of this course, so basically the course TAs will answer to that. So I can't answer that because I
Yeah, I
won't
don't
be
want
setting the.
answer for it. I just want
Okay.
to know, did you get that? Did you means? I mean the team that EE120, right? Did you receive
Yeah.
any email? Because in the I have sent a separate mail from my email account, that is the registered email account, to that EE120 team.
No, I
But
didn't receive any mail.
just a second, the email ID is noc-ee120 at nptel.itm.ac.in.
Yeah, I think so. Yeah.
Okay, okay, I have sent to that thing, but okay, then what I do is I'll also post it in. I will just download it as an attachment and I'll post it in the discussion forum.
Yeah. Okay. Fine.
Okay, sorry, you can stop this initial recording and you can restart the recording process because I have interrupted the training session. Sorry for that.
Okay. Okay. Fine. No problem. So I hope my screen is visible. So if it is, just can you raise your hand and let me know? Okay, fine. Thank you. So today we'll be discussing assignment 4. So assignment 4, which I felt is probably one of the most important topics of power system analysis. So like questions, I mean, you can face some tricky questions from here uh, among all the topics of power system. Yeah. So as the pattern, so we'll be taking some typical questions of assignment 4. So first we'll be starting with some easy ones. Yeah. So let us first start with question 1. So it says that the figure shown above, it is a single line diagram of a power system network. So I hope you are well versed with all these single line diagram, then per unit impedance and all, because the videos have already been given pertaining to these assignments, these questions. So I hope the concepts are clear. Now, the ratings and reactance of various components are shown in the diagram. So consider 100 MVA as base MVA for the whole system. base kV for the circuit of generator 1 is 22 kV. Determine the per unit reactance of transformer 2. So this is very simple problem. I mean, if you know the methods and all. So base MVA is 100 MVA and base kV of the generator is 22 kV. So using this information, what I did, I first calculated the base voltage at high tension side of transformer 1, means basically this side, the transformer, the transmission line. So this is a 22 by 220 kV transformer, and the base voltage of on the lower side of T1 is 22. So just this simple formula, right, of the transformer that we know. So basically, for calculating the base voltage on the higher end, we have to use just the turns ratio ka formula, right? So which is N1 by N2 equals to V1 by V2. So using that only, we get 220 by 22 into 22. So this 22 is the base voltage of the lower voltage side of the T1, so which is 220. So base voltage of transmission line is 220. Now here, this is 115 by 11. So what they have asked is to calculate that per unit reactance of transformer 2. So we have to calculate the base voltage of the lower voltage side of transformer 2, right? So again, using this same formula only, 11 by 115, which is this transformer rating, into 220. So 220 was basically the base voltage of higher side of this, or the transmission line ka base voltage it was. So we get 21.04 kV. Now the reactance is given, it is 0.08. So per unit reactance of transformer 2, it will be, as we know the formula, so the reactance into the new base divided by the old base, right? So the old base of this transformer was 30 MVA and the new, or the base MVA, is 100 MVA. So 100 divided by 30 into square, whole square of, so it is just the inverse of this, what you call MVA, right? The kV. So it will be the old divided by the new. So old kVA was, sorry, old voltage rating was 11 and new one is 21.04. So we do this 11 by 21.04 ka whole square. This is very simple. We get 0.0729 per unit, which is your option B. So 0.073. So this is question number 1. I hope this was clear. So if you guys have any doubt, you can just raise your hand and speak up. Otherwise, we'll go to the next problem.
Yeah, yes, you can proceed. It's clear.
Okay, I hope it's same for others also. So, yeah, so I am allowing mic for everyone. If you have any doubt, you can just unmute and speak. So next problem is also same, but they have asked us to calculate the per unit reactance of motor. So it is exactly the same. Everything is same. So from the above problem, we calculated that base voltage of LT side of transformer 2 was 21.04. So since motor is connected to the lower voltage side of this transformer 2, so this information is useful here, which is 21.04, and the reactance of the motor is 0.05. So again, using the same formula, since the base is 100 MV and 22 kV, so here concentrate on the 100 MVA, not 22 kV. So why I will be telling you. So 0.05 into the new base MVA divided by the old base MVA into the old kV, which was 15 kV, divided by the new kV. So this 22 kV was on the generator side. So this 22 cannot be used here. So instead of that, we calculated the base voltage at the this side, right? The lower voltage side of T2, which was 21.04. So we are using here. So as we did in the above problem, question number 1. So using this again, same thing, we get 0.0508, which is your option number A. This was also pretty simple. Uh, so I hope this was clear. If you guys have any doubt, you can speak up. Okay, fine. So question number 3 is again the same diagram, but here they are asking the question is a bit different. So they have told ki the motor is drawing 50 MVA 0.8 power factor lagging at a terminal voltage VM. So here at the motor, so VM of 15 kV. Determine the voltage of the generator VG, terminal voltage of the generator VG. So we have to calculate the voltage at this terminal, right? At just at the terminal of this generator, which it is generating, not the internal voltage of the generator, but the output at the terminal voltage of the generator. Basically, here I have drawn a diagram, which is the single line diagram here. So we have to calculate the voltage which is being generated at this end. So for this, we need the per unit reactance of each of these components. So meaning transformer 1, then the transmission line transformer 2. So for your information, I have shown the per unit reactance of every component, but we don't need the reactance of G because we are calculating the voltage at the generator end. If we had been told to calculate the internal voltage of the generator, then this information would have been required, right? But we have been told to calculate the terminal voltage of generator. So this information is not required anyways. So using the same formula again, we can calculate the per unit reactance of transformer 1, which is 0.08 into, so the base MVA was 100 and this is 30, so 100 by 30 into, so 22 it was, so no problem with this. It came out to be 0.267. Now, for calculating the per unit reactance of transmission line, we need to calculate the base reactance of transmission line, right? So, sorry, there will be another zero here. So basically, we know that power equals to V square by R, right? So from there, I calculated the base reactance of transmission line. So this is 100 MVA, which represents this, and this will be 220, not 22. So I'll correct this. So it comes out to be 484. So we have the base reactance and we have been given the line reactance. So dividing the line reactance by base reactance gives us the reactance in per unit, which comes out to be this value 0.124 plus J 0.165. Now, reactance of transformer 2 is again the same. So it is given 0.08. So we have this information. So 100 divided by 30 into 11. So we already calculated this in the question number 1 and 2, right? So just for your information, I have shown it here. So this is 0.073 and 0.051. Now, again, we have to calculate. So the total reactance of this line till the generator terminal, right? So till this point. So just so all of these are, since all of these are connected in series, pretty simple. Total reactance will be sum of all these components. It comes out to be 0.124 plus J 0.505. Now, if you go to the question, the motor base voltage was 15, right? And the I mean the motor rated voltage was 15, but we found out that the base voltage of this line was 21.04. So the sorry, this will be motor per unit voltage. I'll correct this, not a base voltage. So it would be the rated voltage divided by the base voltage, right? So it comes out to be 0.713 per unit. Now, just carefully observe this. So we have to calculate the current drawn by the motor, because the formula for calculating the terminal voltage of the generator is the voltage at the motor terminal plus I into Z, right? So this I we have to calculate. So this will be 50. So 50 is this MVA rating of this motor, and your 100 is the base MVA rating. So we get this MVA in per unit, basically 50 by 100 divided by this voltage rating, right? Divided by 1 by 0.1713 into, this is the power factor. So it has been mentioned that the motor is drawing 50 MVA at 0.8 power factor lagging. So 0.8 power factor lagging means cos inverse of minus 0.8, which comes out to be minus 36.87. So your current comes out to be 0.701 at an angle of minus 36.87 per unit. So if you just fit in this formula Vm plus Iz, just carefully calculate this, it comes out to be 1.0214 per unit, which is your option number C. So this was a bit lengthy and a tricky problem, I felt. But if you follow the steps, it is, you'll arrive at the answer. So I hope this was clear. If you have any doubt,
Yeah, I have a question here.
yeah,
This current drawn by the motor, right? That's 50 by
yeah.
100 we have written. Can you just
Mhm.
go to the question? I just want to see the rating, what is mentioned. It's 50 MVA and
50 MVA, and your base is 100. Consider 100 MVA as the base.
okay. Okay, yeah, it's clear.
Okay. I hope it is clear with others also. So if you have any doubt, you can always pick up.
Uh, is it not required to convert that 50 MVA to per phase value?
No, it is not required. See, because
Both are
uh,
same. The base value
it
of
is being
phase and
calculated
line.
in per unit, right? So it
Yeah,
is
okay.
not required. I mean,
Okay.
if
Okay.
you even do it
Yes.
in per phase, the root 3 will get cancelled at some time. So it is not required.
But 100 MVA, we are defining it for the face value, right? Or it is a line
See,
rating.
no, I mean, while you are using per unit, you don't have to consider phase or line values.
Okay.
Yeah. So,
Uh,
for
no, I'll
other,
just. Can you go to the question again? Here you see 30
yeah.
MVA. It is mentioned for transformer one. How
Mhm.
can I consider that one? That is the three phase rating of the transformer, or it is a single phase rating of the transformer? How should I take that one?
No, no, no. All these components are three phase only, because 30 MVA you can't get single phase, right? So, as far as I know, any component with a voltage rating above 5 kV becomes three phase. So, all of these are three phase components.
Okay.
Yeah. Okay. So, I hope it was clear with others also. So, let us go to the next problem. Um, the one-line diagram of a three-phase power system is shown in the following figure. Impedances in per unit on a 100 are marked in per unit on a 100 MVA 250 kV base. The load at bus 3, this S3 is 30 megawatt plus J10 megawatt, and bus 2 is 15 megawatt plus J25 megawatt. So the voltage at bus 3 is maintained at 250 angle 0, so 250 kV. So we have to determine what is the bus voltage at bus bar 1. So basically V1. So in order to calculate this, we have to find out the voltage at bus 2, then firstly current flowing through this line, then current flowing through this load S2, then finally this line, and then we get this voltage V1. So we have been given this base MVA 100 MVA. So S3 is 30 megawatt plus 10 J10 megawatt. So if we convert in per unit, we get, so we just divide it by 100. It is zero point 0.3 plus J zero point 0.1. And similarly, S2 will also be 15 0.5 plus J 0.25 per unit. So this is in per unit. Now, firstly, we have to go from right to left, right? Because we have all the known information at bus number 3, meaning we know what is the voltage at bus 3, which is 250 kV, and we also know what is the power being drawn. So total apparent power, which is zero point 0.3 plus J zero point 0.1 per unit. Now using this formula, S3 equals to V3 into I star. So I star is basically the conjugate current, right? This is the formula if you know. So this is how we write this thing. So I3 is zero point 0.3 plus J zero point 0.1. Now if we remove the star, so just the conjugate of this would be 0.3 minus, so plus becomes minus, so it becomes zero point 0.3 minus J zero point 0.1. Now, we have this I3 ka value. So V2 will be just, so this I3 is only flowing through this, so this line between V2 and V3. So V2 is V3 plus I3 into Z23. You just fit the values, everything, do it carefully. You get 1.19 plus J 0.07 per unit. So we have the value of V2. Now similarly V1 would be, so this line would be V2 plus
Hello.
hello. Can you guys hear me?
Oh yes, now I can hear you. We
Yeah,
lost
yeah,
you
yeah.
for,
Okay.
or I lost you for a few
Yeah, yeah.
minutes, last 2 minutes.
So could you please let me know till where did you listen? At, to which point?
The conjugate, I3
Okay.
conjugate
Okay,
conversion.
okay, fine, fine. Yeah. So I3 is zero point 0.3 minus J zero point 0.1. So using this, we can calculate V2. So which is V3 plus I3 into Z23. So you do this. We know every value. So V1 is 1 because sorry, V3 is 1 because V3 was if you notice the voltage at bus 3, it is 250 kV and our base was also 250. So it comes out to be 1 per unit. So you calculate this, it comes out to be 1.19 plus J 0.07. Okay. So now V1 would be V2 plus I1 into Z12. So Z12 is this real impedance of line 1 and 2. So zero point 0.4 plus J 0.25. But if you notice I1, so I1 is the sum of this current and this current, right? So the current which is flowing between this, the line between V2 and V3 and also through this load 2, which is I2 plus I3. So we have to calculate I2, right? We know what is I3. We just calculated, which was zero point 0.3 minus J 0.01. So what would be I2? It would be S2 by V2, right? Because S2 is the power being drawn from bus 2. So we also have the information of S2, which is 0.15 plus J 0.25. So if you do, and we also just calculated what is the value of V2. So if you calculate this, it comes out to be this value 0.137 plus J 0.2015. So again, this is a conjugate. So because as we use this formula, so S3, so this will be S2 equals to V2 into I2 star. So I2 would be, this plus would become minus 0.137 minus J 0.2015. So using this, we have I2 ka value and we also have I3 ka value. We calculate what is I1. Now again, we fit in this formula. We know what is V2, which we calculated here. So this is 1.19 plus J 0.07 plus this current into this line ka impedance, which is 0.4 plus J 0.25. So if you carefully do this, it comes out to be this value. So you just calculate the what is the magnitude of this. So root over 1.441 whole square plus 0.059 whole square. So whatever you get, you have to multiply it with 250 kV, because in question they have asked the value not in per unit. So we have to calculate what is in kV. So since base voltage was 250 kV, so whatever is the value of the voltage in per unit, we have to multiply it with 250. So it comes out to be 360.5 kV, which is option number D. So I hope the process was clear. I am audible, right? Hello.
Yes, yes, you're audible.
Okay, okay.
You can
You
move on. Yes,
understood the
clear.
problem, right?
Yes, yes.
Okay, fine. So we go to question number 6. Um, so the what I feel is that by looking at the question, you feel that the question is big, but this such huge statement basically describes what is the I mean, what are the different components shown in the diagram. But apart from that, the I mean the question is pretty short. So if you go look at question number 6, it has been told that 80 MVA 33 kV three-phase generator has a subtransient reactance of 10%. So the generator is connected to the motors through a transmission line and transformer. So the motor rating M1, M2, M3 are 30, 25, and 40 MVA. And each motor is rated at 20 kV and subtransient reactance of 0.12. So the three-phase transformers are rated at uh, 100 MVA 32 kV. So this is basically delta star. So this side is so the I mean which side is delta, which side is star, they haven't mentioned. So anyways, we don't have to worry about that. So 32 kV 100 kV transformer with a leakage reactance of 6%. Now the line has an impedance of 20. So this transmission line has an impedance of 20 plus J40 ohm. So they have told that we have to select the generator rating as the base quantity. So our base becomes 80 MV and 33 kV. So they have told what is the per unit impedance of the line. So this is pretty simple. So using this same concept, so we have to calculate what is the base voltage at the transmission line side or the high voltage side of transformer one. So we know what is the voltage ratio of transformer one, which is um, what 100. So sorry, this will be 110. I made a mistake here. I'll correct this. So this is 110 by 32, and we have the base voltage which is 33 kV. So we get the voltage rating at base voltage rating at the high end, which comes out to be 113.44. So again, using the same concept, we calculate the base impedance of the transformer transmission line, which is this using that formula, power equals to V square by R. So this is the voltage and this is the MVA rating.
Hello?
Guys, are you able to hear me? Hello?
Shobi, can you hear me? This is Lakshmi.
Yeah. I can hear you.
But I lost your screen.
Okay. Wait, I am facing some problems.
Okay.
Wait, just wait. Give me some time. Can you see my screen now?
Yes.
Okay. Fine. So we calculated what is the base voltage of the high voltage side of transformer one, which was 113.44 kV. So base impedance we calculate using the same formula, which comes out to be 160.85. Now the using this, so we have uh, the reactance or the impedance of the transmission line, which is 20 plus J40 ohm, and we also have the base impedance of the transmission line, which is this. We divide it, we simply get the what is the per unit impedance of the transmission line, which is 1.124 plus J.249, which is option number D. So this was pretty simple problem. I hope this was clear.
Yeah, it is clear. I just have a question.
Yeah.
In case of transformers, we are representing the transformer impedances in percentage.
Hmm.
Is there any habit or practice to represent the line value also in percentage? Because in transformer, I can understand the values, the reference values are taken as its own rating, its own MVA, its own voltage is taken as reference, and the manufacturer represents the value in a percentage, and we are converting it into a new base based on our SLD and voltage levels. What about the transmission line? Will they only mention it in terms of R plus JX generally?
Yeah,
Or
because see, I mean, what as far as I know, this transmission line has a certain distance, right? So it changes with the distance, the reactance, and as well as the resistance. So that is why with fixed distance, it will have some fixed impedance. So due to that reason, I think it is always given in this ohm and not in percentage.
okay, but in that case, they could have represented in per unit per kilometer value. We can
But that
convert it
again
if they
becomes
mention
a
the line length directly,
that
that
again
can be
becomes a
converted.
bit complex, right? Because
Okay.
you have to again multiply it with the
Okay. Okay.
distance and all extra
Okay.
step.
Thank you. Yes. Okay.
Okay. So now same problem, question number 7. So the statement is a bit different here. So everything is same. Here only they have asked us to calculate. So they have mentioned key if motor M2 is taking a current of 1.25 per unit at 0.75 power factor leading at its rated voltage, find out the per unit magnitude of internal voltage of M2. So we have to calculate what is the internal voltage of M2. So if you know what is the how to calculate the internal voltage, so basically this is the formula. So VM2 would be the voltage which is being generated. Which is the terminal voltage of the motor, and VM2 is the internal voltage, right? So we don't have to calculate any the per unit impedance of any of these components. So all of these are extra information. They have been given to confuse all of us. So we just have to follow this formula. So mm, again we calculated that. No. So in the previous problem we saw that the base voltage of the the higher side of transmission transformer 1 was 113.44. So using the same information, we have to calculate what is the voltage at the lower side of transformer 2. So again, the turns ratio or the voltage ratio is 32 by 110. So using this, we get 33 kV, which is the base voltage of M2, or I mean all of these motors, right? And also this transformer 2. So we have to now calculate what is the per unit impedance of motor 2, which is 0.12 into this 80, which is the base, our base MVA, and the MVA rating of motor 2 was 25. So 25 into the old motor rating was 20 kV. So 20 kV divided by the new base voltage rating, which is 33, which comes out to be 0.141 per unit. Now, uh, again, we require this. What is the per unit voltage at the motor terminal, which is the rating divided by the base voltage, which is 0.6061 per unit. Now, see here, I have tried to solve this problem in a different way. So we require what is the require to know what is this current, right? IM2. So for this, this in per unit, right?
Show me just a minute here. This rated current,
Yeah.
do we need to not add the root 3 parameter here in it? If it's the rating of the machine is 25 MVA and it's
See,
20
yeah, I
kV.
am telling you. Yeah, I'm coming to that. Yes.
Okay.
So rated current of M2. So what I have done. So this is 25 into 10 to the power 3 by 20. So 25 is the MVA rating of this motor, and 20 is the rated voltage. So here, even if you add this root 3, right? So suppose you add this root 3 here, fine, you do that. Okay, now in the next step you see that I have tried to calculate the base current, right? So we have the base MVA and the base voltage. So again, if you try to add any root 3 here, you do. Finally, we have to calculate the ratio of these two in order to get the per unit current. So anyways, this root 3 gets cancelled. So there is no point of calculating the line current or phase current, I mean using root 3. So it gets cancelled. So I mean the um process becomes much more simpler. So that is why I didn't use any root 3 here, because it gets cancelled while you divide the rated current by base current. So it comes out to be 5.5156. I hope this was clear.
Yeah, it is clear now. Actually, in base current also, we should have taken the root 3 value. In that case,
Yeah. See.
both will cancel.
I
Yes.
know. I get your point. You can do that. No problem with that. But if you, even if you use, and when you divide this rated current by base current, this root 3 will get cancelled, right? So there won't be any effect of root 3 because you are calculating the per unit, which has no unit basically, this component. So there won't be any effect of root 3. So that is why I didn't use any root 3 here.
Okay, yeah, it is clear now. Yes.
Okay. Uh, Anyways, when you try to do this, you include root 3 and then try. I hope, I mean, you will arrive at this answer only. I hope, I mean,
So the usual practice when we are converting or when you are getting the calculating the current of motor, okay, we'll take a three-phase power and divided by the root 3 parameter. So we'll get the line current. That is one way. Or
yeah,
converting the MVA to a single phase, then voltage also to a single phase, then we will get a single phase current, which is also a line current. Both will be equal. But this looks to be somewhat different. We have used the three-phase MVA, and in the calculation we are using the single phase. Sorry, what is this? 20 kV is line
yeah.
current,
So
right?
I
Line
get what
voltage,
you're
yes.
trying to say. Yeah, I get what you're trying to say, but
What I
since
think
we
is
are,
here the rated current of M2, right? That
Mhm,
though this calculation in IM2 per unit we are getting the right value, but rated current of
mhm,
M2 is not 1250. What I'm thinking is it should be 1250 by root 3. That is the rated current of M2. But as a calculation as a whole, up to IM2 in per unit, that will be
mhm.
fine. We are going to get the same value. But rated current of M2 will be, if the question is asked like give a rated current of M2 also, then the rated current of M2 must be
Yeah, then
1250 by
yeah,
root 3.
yeah, exactly. True.
Yes. Okay.
If they have asked you to calculate the rated current of M2, you have to use root 3. Yeah, fine. Yeah,
Okay.
I
Okay.
agree.
Yes. Thank you. Yes.
Fine. Yeah, so that is what I was trying to tell. So when you are trying to calculate the per unit value, you don't have to worry about root 3 because this will get cancelled. Yeah, fine. So we now have this value. So current in per unit. So we just have to fit in this formula. So we have the value of VM2, which was 0.6061, and we also have this current ka value. Now power factor leading. So this is 0.75. So cos inverse of 0.75, and there is no minus since this is leading. So 41.41 into, so the reactance we calculated, so it is 0.141, so 0.141 90 degree into 90 degree. So you calculate this, it comes up to be 0.656 per unit, so which is option number C. Yeah, so I hope this was clear.
Here 0.75 we are converting into degrees 41.41.
Yeah, yes.
Do we not, there is no need to add negative sign in it?
No, this is
It's a leading.
leading na. This is leading part factor.
Oh,
If,
okay,
if it
sorry,
was
yeah,
lagging,
yeah,
then we
okay,
had
yeah, it's
to
leading.
include
Okay,
minus,
yeah,
right?
yeah. I have not noticed that part clearly. Okay then.
Yeah. Okay. So we come to question number 8. So again, this is a pretty big, diagram. So basically, this generator one is connected to this bus bar one. So where there are two parallel lines. So T1, T2, T3, and T4 are four transformers. So between T1 and T2, there is one transmission line which has a reactance, not base, so, which has a reactance of 45.5 ohm, and line 2 has a reactance of 50.5 ohm, and all of these components rating and all have been mentioned here. So they have asked us to determine what is the per unit load impedance. right? So now again they have told key, so consider base 100 MV as base for the whole system. So I have taken 100 MV as the base and also this 22 kV as the base voltage. So again using the same concept, I calculate what is the base voltage of this transmission line one. So which is 22 into this turns ratio. So 220 by 22, which is 220 kV. And again,
Hello, uh, Yashwant or Rajneesh, can you hear me? Shobik, we can't hear you.
Hello, Lakshman, can you hear me? Hello.
Yes,
Sorry. I am basically facing some issues with my PC.
no
That's
problem.
why. Yeah. Thank you for staying back. Huh?
Yeah, no problem.
So, can you see my screen?
Yes,
Yeah. Okay. So we were discussing problem number 8, right?
yes,
Yeah. Okay. So, so here basically we have these two lines which are connected in parallel. So all of these four components are connected. So at the end there is a load which is of this rating. So mind you, this is zero point 0.8 power factor lag. So they have told us to determine what is the per unit load impedance. So base is 100 MVA and I have taken the base kV as 22 kV. So base voltage of transmission line 1, using this same thing we calculate, we get it, so 220 by 22 into 22, so 220, and similarly in the same way for transmission line 2 as well, so 110 by 22 into 22, it is 110. Again, using the same formula, we calculate the base voltage at lower voltage side of T2 and T4, we get 11 kV both. So now we see that the load voltage is rated at 15 kV. So the load voltage in per unit would be 15 by 11. So it is per unit. So again, the same formula, the current drawn by the load would be the MVA divided by the voltage, right? So again, you see that I am not using any kind of root 3 here while calculating, because all of these would get cancelled eventually because we are calculating in per unit. So you see that the voltage, the load is at 50 MVA. So 50 divided by the base MVA, 100. Again, the voltage in per unit, it is 15 by 11, and the power factor is also mentioned. It is zero point 0.8 power factor lag. So cos inverse of minus zero point 0.8, so 36.87. So I have kept it as it is. I haven't simplified it because we have to calculate the load impedance in per unit, right? So load impedance would be nothing but this voltage divided by this current. So basically 15 divided by 11 divided by this pura term. So when you do this, you get 3.72 at an angle of 36.87. So it is option number A. So I hope this was clear, especially this part, the current wala part.
yes,
Yeah, okay. So now your confusion is clear, right? So why am I not using any kind of root 3 while using these three phase components?
yes. Had a confusion there because we are mentioning it as current drawn by load or something, right? So I expected the calculation to happen in that usual formula.
No,
That
just
yes, now
I
it is
mean,
clear.
yeah. So we are doing everything in per unit, right? So that is why we don't have to worry about all those. So that is why I haven't written. Otherwise, I mean, you can write everything. I mean, do it conventionally, and then also see that it would, the result would be the same. So that is why. Yeah.
Okay.
So now in question number 9, again the same thing, but here so they have mentioned to determine what is the magnitude of terminal voltage of generator. So again we saw a similar problem. So we have to determine what is basically the voltage at bus bar 1, right? Because the generator terminal is only feeding the bus bar 1. So we have to determine this voltage. So for this, we have to calculate the per unit reactance of every component. So T1, T2, line 1, line 2, T3, T4. So I have calculated all of this. So the formula remains the same, which I had shown earlier. So I have, you see, I have calculated all of this. Now I have drawn a simple diagram here. So where this is the generator and this is the motor, and this is for transformer 1, transformer 2. So this is line 1, line 2, and this is, sorry, this is T1, T3. Yeah, T1, T3, then T2 and T4 ka per unit impedances. So now we know what is the voltage at this point, right? What is the motor terminal voltage, right? We calculated this. So this was 15 by 11 per unit. So we have to calculate what is the voltage at this, and we also know what is the current, right? So which was this. So now we know what are the impedance or the per unit impedance of each of these components. So this is just, I mean, this is a line, this is a line, they are connected in parallel. So here I have shown it. So all of these are impedances, right? So that is why I have written J at the outside. So 0.25 plus 0.094 plus 0.167 ka parallel of 0.2, 0.4174, and again 0.2. So if you calculate this, it comes out to be J 0.3144. Now this is pretty simple. So voltage at the generator terminal would be Vm plus I into this Xeq. So I comes out to be, so if you simplify this, if you simplify this term, so it comes out to be 0.367 at an angle of minus 36.87. So pretty simple, 15 by 11 into this current into this value. So 0.3144 at an angle of 90 degree. So if you calculate this, it comes out to be 1.433 plus J 0.0923. Now I think, yeah, so you have to calculate what is the magnitude, right? So just take the square root of this term, so you will get it around what, 1.445, something like that you'll get. So this is question number 9. I hope this was clear.
Yes.
Yeah, okay. So finally question number 10, it's pretty easy. So they have asked what is the per unit impedance of a circuit element is 0.25. So if the base kV and base MV are half, so both are half, then the new value would be, so we know per unit impedance is directly proportional to the MVA rating, and it is inversely proportional to the square of the kVA rating. So if you just place the value, so MVA rating is half and kVA rating is basically double, right? I mean, half of square. So this 4 comes out to the top. So half into 4. So it comes out to be 0.5, which is your option number C. So this was pretty simple, really very easy problem. Now this I haven't solved. So I mean, using the concept of the previous problems, I hope you can solve this problem. And I have also, I mean, if you can't solve this problem, you can get back to me, so I can provide you the solution to this. So answer would be this option number D. So they have told what is the power. So what I suggest for this type of question, you first try to draw the diagram. What is the diagram of this system, whole system, and then try to solve it. First write the what are the ratings of the different components, then find out what is the per unit impedance, and then find the current voltage, and finally the what they have tried to ask. So if you do this question, answer number D. So this was about it for today, and I'm really sorry, I was facing a issue with my internet connection, so it was continue, I mean, fluctuating too much today. Sorry for that.
Yeah, no problem. That's not an issue. And
Yeah,
is it completed?
yeah, it's completed. Yeah.
Okay. It's again about the calculator part again. I have sent an
Huh.
email or conversation in that groups. Just check it. Did you receive it or not? And you can respond it to that later. Okay.
Okay, you have written to the discussion forum, right?
Yes, because I was advised to write it to the discussion forum only from the services or support.